many people are waiting for a perfect moment that never comes. We don't need mastery, we need a program. Don't aim to be the best in the world, aim to be the better than the version of you yesterday. Today, I want to take you on a journey to rediscover the power of listening quietly. A quiet guy listens to all sides and then gives a solution that nobody thought of. Hope everyone listens and learn more out of this video. And now let's get started with today's topic on test of significance small samples. When the sample size is very small, less than 30, so we choose student t-test or f-test. So here in this video, I am going to choose f-test. So here I have already given you the solutions for example 1 and example 2, and here are the solutions for example 3, 4, 5 and 6. Example 3. Two random samples reveal the following results. Samples. Sample 1 and sample 2 size 10, 12. The sample size n1 is equal to 10 and n2 is equal to 12. Sample means 15 and 14, that is x bar is equal to 15 and next one x2 bar is equal to 14, and the sum of the squares of the deviations from the means are 90 and 108. And now we have to test the samples came from the same normal population. So this is what we have to follow, that is we have to test the samples from the same normal population. So here is the solution. So in the solution, as usual, we have to go with the null hypothesis. The two samples have been drawn from the same normal population. So H0 is equal to mu1 is equal to mu2. Here we have to use two tests. As the sample sizes are less than 30, that is 10 and 12 which are less than 30. So we are going to test the equality of the variance by f-test, and we are going to test the equality of means by the t-test, student t-test. See here, first thing is the f-test, the equality of variances. So n1, the sample size n1, this is the sample size n1 is equal to 10 and n2 is equal to 12. And next one, the means x bar 15, x1 bar is equal to 15, and this is x1 bar and this is x2 bar. So this is n1 and this is n2. See clear? N1 and N2. See here, the sum of the squares of the deviations from the means, that is sigma xi minus x bar whole square is equal to 90 here from the table. And next one, sigma yi minus y bar whole square is equal to 108. So this is the data taken from the table here. And next we have to check the test of variances using the f-test. S1 square is equal to sigma xi minus x bar whole square by n1 minus 1. So what is sigma xi minus x bar whole square? This is 90. What is n1 here? 10. That is 10 minus 1 which is equal to 9. So S1 square we got as 10. And S2 square is equal to sigma yi minus y bar whole square by n1 minus 1. What is sigma yi minus y bar whole square? That is 108. What is n2? Here n2 is equal to, so this is n2. n2 minus 1, that is 12 minus 1 which is equal to 11. The value here is 9.82. So among this 10 and 9.82, which is bigger? 10 is bigger. So f1 square should be in the numerator and s2 square should be in the denominator. So depending upon the values of s1 square and s2 square, so the test statistics f formula will be decided. So f is equal to s1 square by s2 square, that is 10 by 9.82. The value here is 1.018. See here, the calculated value is f is equal to 1.018. Now at 5% level of significance, so the degrees of freedom will be n1 minus 1, comma, this is n2 minus 1. What is n1 here? So n1 is equal to 10. 10 minus 1, 9, comma, and this is 12 minus 1, this is 11. So we have to check in the table here. So F distribution table. So this is the table value. So the critical values of F distribution. So for 5% level of significance, V1, comma, V2. The first one is V1. So what is V1 value? 9. So at 9 we have to check. See here, we have to go with 9 and again with 11. So this is 11 and this is 9 and the value here is 2.90. See here, 2.90. So this is 2.90 from the table. So this is the calculated value, that is 1.018, and this is the tabular value, and it is very clear that the calculated value is less than the tabular value, and therefore we have to accept the null hypothesis, that is sigma 1 square is equal to sigma 2 square. The variances are equal. The samples came from the same normal population with the same variances. So according to the F-test, we have checked that the calculated value is less than the tabular value. And next, coming to the student, to test the equality of means, we have to go with the student t-test. See here, For student t-test, to test the equality of the means, again null hypothesis mu1 equal to mu2, and given x1 x1 bar is equal to, see here, x1 bar from the table is 15, x2 bar is equal to 14, n1 is equal to 10, and n2 is equal to 12 here, and sigma xi minus xi bar is equal to, see here, sigma xi minus xi bar here is 90, and sigma yi minus yi bar is equal to 108. So all the values are ready here, and now we have to go with s square. So s square formula is the sigma xi minus xi bar whole square plus the sigma yi minus y bar whole square by n1 plus n2 minus 2. So this value is equal to 90 plus this is 108 divided by n1, that is 15. So this is n1, 10 plus 12 minus 2. The value here is 9.9. So this is s square. So this is the variance value, and we need the standard deviation. Therefore, the standard deviation is equal to root over 9.9, and therefore the standard deviation is equal to 3.15. And 3.15. From the table, we have x bar is equal to 15, y bar is equal to 14, standard deviation is 3.15. Just now we found out n1 is equal to 10 and n2 is equal to 12. According to the test statistics for test statistics, t is equal to, see here, this is the formula, x bar minus y bar by s times of root over 1 by n1 plus 1 by n2. So this is n1 plus n2. So x bar is equal to 15 minus y bar is equal to 14 by standard deviation here is 3.15 by root over 1 by 10 plus 1 by 12. The value here is 0.75. So the calculated value here is 0.75. And now we have to go with the tabular value. So for tabular value, the degrees of freedom is n1 plus n2 minus 2. What is n1 here? 10 plus 12. So this is 10 plus 12 minus 2. So here it will be 20 degrees of freedom. At 20 degrees of freedom, so I'll show you at 5% level of significance. So here it is student t distribution table at 20. We have to go with 5% level. So here, see, at 20, at 5% level, that is 2.086. So at 5% level, so this is a 2.086 from the table, and this is the calculated value, and this is the tabular value. Clearly, calculated value of t is less than the tabular value, and therefore we are going to accept the null hypothesis, and therefore mu1 equal to mu2. Hence, from 1 and 2, the given samples have been drawn from the same normal distribution. Hence, we accept the null hypothesis. So mu1 equal to mu2 and sigma 1 square is equal to sigma 2 square. So this is how we have to check. So we have to check the means, equality of the means using student t-test, and the equality of variance using the f-test. And this is also very important question. And the next question here is the fourth question here. So what is this fourth question here? So it is known that the mean diameters of the rivets produced by the two firms A and B are practically the same, but the standard deviations may differ. For 22 rivets produced by firm A, the standard deviation is 2.9, while for 16 rivets manufactured by firm B, the standard deviation is 3.8 mm. Now we have to compute the statistics that we would use to test whether the products of the firm A have the same variability of those of the firm B and test its significance. So we are going to test its significance. As usual, for the solution, so we have to go with the null hypothesis. So for null hypothesis, sigma 1 square is equal to sigma 2 square. For alternate hypothesis, sigma 1 square not equal to sigma 2 square. N1, here 22 rivets. So N1 is equal to 22, and next one 16 rivets, N2 is equal to 16, and the standard deviation here is 2.9 mm for the first firm, and next one for the second one is 3.8. So these are all the data given, N1, N2, S1 and S2. Since the standard deviations are of the samples S1 and S2 are given, see here, sample population S1 square is equal to, this is the formula, S1 square, capital S1 square is equal to N1 S1 square by N1 minus 1. What is N1 here? 22. See here, 22 divided by 22 minus 1, that is 21 into S1 square. See here, 2.1 whole square. The value here is 8.808. And next one, so this is the formula for S2 square. So this is also very simple, that is N2 S2 square by N2 minus 1. What is N2 here? N2 is equal to 16. This is 16 divided by 16 minus 1 is 15, and S2 square is 3.8 whole square. The value here is 15.393. So among these two, which one is bigger? S2 is bigger. So we have to write the formula as S2 square is greater than S1 square. For test statistics, F formula will be S2 square divided by S1 square. So whichever it is bigger, we have to write in the numerator. That is the logic. If S2 is bigger, so we have to write in the numerator S2 square by S1 square. So here this is 15.393 divided by 8.805, and therefore the F value, the calculated value is 1.74. The calculated value of F is very clear. And therefore next one we have to check the tabular value. The tabular value of F for degrees of freedom, clearly n1 minus 1, and this is n2 minus 1. What is n1 here? N1 is 22 minus 1. This is 21 comma n2. What is n2? 16. 16 minus 1 is 15. So we have to check at 5% level of significance. So for F distribution at 5% level of significance, and let me show you, this is 21 comma 15. So at F distribution for 21, so for 21 we have to see in this way. This is 21 comma, this one is 15. This is 2.20. So here this is 21 comma, this one is 15, that is 2.10. The value here is 2.10, or here they wrote as 2.20. So this is 21 comma 15. So there is no 21 in this table, and therefore the nearest value they have found. So at 15, see here 21 and 15, so this is 2.29. So this is 2.29 here. So write 2.29. So this value is 1.74 and this is 2.20. Therefore the calculated value of F is less than the tabular value, and therefore we are going to accept the null hypothesis. We are going to accept the null hypothesis H naught, and therefore the products of both the firms A and B have the same variability. So we may conclude that the products of the firms A are not superior to that of firm B. And next, coming to the fifth example here, the pumpkins were grown under the two experimental conditions. Two random samples of 11 and 9 pumpkins show the sample standard deviations of their weights as 0.8 and 0.5 respectively. And now, assuming that the weights distributed are normal, test the hypothesis that the two variance are equal. So talking about the variance, we have to go with the F test. F test, as usual, null hypothesis sigma 1 square is equal to sigma 2 square, and the variances of the sources are equal, and alternate hypothesis sigma 1 square not equal to sigma 2 square. Here n1 is equal to 11, n2 is equal to 9, and the standard deviation is 0.8 S1, and this is S2 is equal to 0.5. Here the sample standard deviations are given, and now we have to determine the population variance as capital S1 square and capital S2 square by using the relation here. So this is the formula here. For capital S1 square, the formula here is very simple. That is n1 by n1 minus 1 into S1 square. What is n1 here? n1 is 11. This is 11 by 11 minus 1. This is 10 into. This one is 0.8 whole square. The value here is 0.704. And for S2 square, the formula is also very clear. That is n2 by n2 minus 1 into S2 square. What is n2 here? 9. This is 9 by 9 minus 1, 8 into. This is 0.5 whole square. The value here is 0.281. So among these two, which one is bigger? S1 square is bigger. So here, for our test statistics, the formula varies. So for test statistics, which one is bigger? That will be in the numerator. That is F is equal to S1 square by S2 square. That is 0.704 by 0.281. The value here is 2.5, as S1 square is greater than S2 square. So here the calculated value is 2.5. F is equal to 2.5. And next we have to check the degrees of freedom. The degrees of freedom will be n1 minus 1, and this is n2 minus 1. What is n1 here? n1 value is equal to 11. 11 minus 1, this is 10 comma n2 is equal to 9. So this value is 8. At 5% level of significance, we are going to check at 5% level of significance at 10 comma 8. At 10 comma 8, the value here will be, see, the calculated value here is, see, for F distribution at 10 comma 8, the value here is 3.35. So for 10 V1 and 8 V2, 3.35. So see here, this is 3.35 at 5% level of significance at 10 comma 8. Since the calculated value on comparing these two, 2.5 and 3.35, this is the calculated value and this is the tabular value. Calculated value is less than the tabular value, and therefore we are going to accept H naught at 5% level and degrees of freedom 10 comma 8, and therefore we conclude that the variance of the two populations is same, and therefore the two samples have the same variance. This is how we have to check, and the formula is also so simple. If n1, n2, small s1 and small s2 are given, this is the formula which we have to take for the population samples s1 and s2. Among these two, which one is bigger, that we have to keep it in the numerator for finding the test statistics. And the calculated value is very clear as 2.5, and the tabular value, so every time we have to take the tabular values and we have to compare the calculated value as well as the tabular value, and therefore if it is less than we have to accept, if it is greater than we have to reject, and therefore the two samples have the same variance. And the next one is example 6. So here is example 6. The time taken by the workers in the performing a job by method 1 and method 2 are given below. So this is method 1 and this is method 2, and this is the data here. 1, 2, 3, 4, 5, 6. N1 is equal to 6. 1, 2, 3, 4, 5, 6, 7. N2 is equal to 7. And next, do the data show that the variance of the time distribution from the population from which the samples are drawn do not differ significantly? Here they are asking particularly about the variance. So if they ask about the variance, we have to take which test? F test. So as the n value is less than 30, we have to take the small sample test and we have to go with the F test. As usual, for null hypothesis here, sigma 1 square is equal to sigma 2 square, and sigma 1 square and sigma 2 square are the variances of the population from the samples are drawn. And alternate hypothesis, sigma 1 square not equals to sigma 2 square. Clear? And see, this is the data given. So here x values 20, 16, 26, 27, 23 and 22. So they are kept under column 1. And here n1 is equal to 1, 2, 3, 4, 5, 6. N1 is equal to 6 here. So we have to make an addition, that is 134. And x bar is equal to sigma x by n1, that is 134 by 6. The value here is 22.3. So from each and every value, we have to subtract 22.3. So 20 minus 22.3 is minus 2.3, 16 minus 22.3 is minus 6.3, 26 minus 22.3 is this one. So we have to fill this column and we have to make a squares. That is minus 2.3 whole square is 5.29, minus 6.3 whole square is 39.69, and so on. We have to fill the second column. And the next one, these are all the y values from the given data. So method 2. 27, 33, 42, 35, 32, 34 and 38. We have to fill in fourth column. And next one, the y bar here. So we have to make a total. This is 241. So here sigma y by n2. N2 is equal to 7. That is 241 by 7. The value here is 34.4. And now we have to subtract 34.4 from each and every value of y. 27 minus 34.4 is minus 7.4, 33 minus 34.4 is minus 1.4, 42 minus 34.4 is 7.6. Like that we have to fill this column and we have to make a squares. That is minus 7.4 whole square is 54.76. Like that we have to fill this column and we have to make an addition out of these. So here this will be sigma xi. X minus x bar whole square, this is a sigma y minus y bar whole square. So these are all the totals here. So this is a sigma xi minus x bar whole square is 81.34 and sigma yi minus y bar whole square is 133.72. For S1 and S2, be the estimates of sigma 1 and sigma 2. For S1 square, the value here is sigma xi minus x bar whole square by n1 minus 1. So this is 81.34 by n1. What is n1 here? This is 6 minus 1, 5. The value here is 16.26. And for s2 square, this is sigma yi minus y bar whole square by n2 minus 1. This is 133.72 by n2 minus 1. n2 is equal to 7 minus 1. The value here is 6. That is 22.29. So here among these two, which one is bigger? S2 square is bigger. So as S2 square is greater than S1 square, for test statistics, the formula will be, whichever it is greater, it should be in the numerator, that is s2 square by s1 square, that is 20.29 by 16.268. The value here is approx 1.37. The calculated value here is 1.37. And for degrees of freedom, n1 minus 1 and n2 minus 1. What is n1 here? N1 is 6 and n2 is 7. That is 5 comma 6 will be, 5 comma 6 is the degrees of freedom, as n1 value is equal to 6 and n2 value is equal to 7. We have to subtract one element. So this is 5 comma 6 at 5% level of significance. So here we are going to check from the table here, 5 comma 6. So this is SF distribution. So the value here is 5 V1 and 6 for V2, that is 4.39. So here the value is 4.39 from the table. So the calculated value is 1.37 and the tabular value is 4.39, and therefore the calculated value of f is less than the tabular value. And now we are going to accept the null hypothesis at 5% level of significance, and therefore there is no significant difference between the variances of the time distribution by the workers. And this is how we have to check, and each and every time from the given data we have to calculate s1 square and s2 square. So among s1 square and s2 square, whichever it is bigger, so we have to take it in the numerator, and this will be the calculated value, and going to the table. So the tabular value, we have to compare the calculated value as well as the tabular value. If it is less than, we have to accept. If it is greater than, we have to reject. And this is how we have to solve these are all the problems directly from the textbook, and everything you have kept in your hands, and it is your turn to practice, score and celebrate. Thank you so much for watching and staying till the end. So many videos are uploaded in the playlist. Please share the playlist to as many friends as you can. That is the greatest help needed to this channel. And thank you so much.